Mister, we can't hear you.
Now you can hear me, right?
Yes, Mister.
Okay, very good. So I was talking about the electrochemical cell that we discussed last time, that it made from anode and cathode. The anode is negative, the cathode is positive, and we can use that to produce electric current. What we are going to do today is determine what is known as the half cell and the cell potential. So what is electrical potential? That's what we are going to, these are the objectives for today, is to identify the cause for electrical potential. Well, first of all, we have to define what is electrical potential, and then to look on the cause of that. Why in electrochemical cell we have electrical potential? And then we need to determine the standard reduction potentials of half a cell. And then the last part will be to decide or to determine whether a reaction is going to be a spontaneous, which means that it is a voltaic cell, or it is non-spontaneous based on the value of the electric potential of the whole cell. That's what we are going to do. Okay, now moving on, electrical potential. First of all, what is the meaning of that? Electrical potential is the tendency or the ability of any electrochemical cell to produce electric current. Because when you have two half cells like these, okay, like for example, having X element here and Y element over there, and then you connect them with a salt bridge also, and you have a light bulb or whatever over here, there's an amount of electric current that will produce. Now, that amount definitely depends on X and Y, what they are. I mean, if we change that into V and Z, for example, different elements, then the amount of electric current will be different. And that's why what we call electrical potential. Electrical potential is the ability of an electrochemical cell to produce electric current. So on that basis, it's a measure of the ability of that, how much the ability to produce electric current, and usually we use the volt in order to do that. Now, what causes that? What is the reason for this? First of all, we have to state a fact that in order to measure the electrical potential, we can do that for an electrochemical cell with anode and cathode. But if you have one half cell, isolated one, you cannot measure it because you have to measure it reference to something. So having, for example, the zinc half cell by itself, that will be not possible to measure. Yani, if you have the zinc over here with electrode and everything, but there's nothing in there, so how would you measure the electrical potential of the whole cell, or even for that one? That is going to be impossible. But if I put copper over there, and then I can measure the difference between them. So you cannot, that's a fact. You cannot measure the electrical potential of an isolated cell, but you can measure the electrical potential of the whole cell by measuring the difference between the two. Okay, so whatever we are reading over here of electrical potential, that is equal to the difference between copper and zinc. So if I know one of them, then I can determine the other one. Usually what we are going to see later on is that we or they decided about using something as a reference. Yani, why the negative is negative? Because relative to the zero. Why the positive is positive relative to the 0 too? So we have, let's say, the 0 over here. This is 0. And then the values of 1 and 2 and 3 and 4 is nothing without a 0. That's why when the Indians, they discovered the 0, it was a big revolution in the mathematics, because that is the meaning of 1 and 2. Also the -1 and -2 and so on, they are relative to the 0. So the same thing over here. In order to be able to determine the electrical potential of half a cell, you need to have something here with the 0 value, so that the difference over here is going to be equal to that one. So that's why they invented what is known as the standard hydrogen electrode. I'm just giving you an overview of what we are going through. So the electrical potential of a cell results from basically a competition, because it's the difference. So that's a competition between the two half cells on the electrons. Which one will gain the electrons? Now, the one which have the greater tendency to gain the electron is the one which will undergo reduction, right? Because basically reduction is about gaining electrons. So the half cell that has a great tendency to acquire electrons is the one which will undergo reduction and will be in the cathode side. By default, the other one will be for oxidation. This is going to be our main job here. Now, in the past, when we decide which one is oxidized, which one is reduced, we used to refer to the activity series. The one is in the top is always oxidized, right? And it will reduce anything that is below it. That's what we agree. But we're not going to use that anymore. We're now going to calculate the electrical potential and decide accordingly which one is to be oxidized and which one to be reduced. Okay, so the tendency of half a cell in a reaction to occur as reduction is called reduction potential. So we're not using any more electrical potential of the whole cell. We're talking about reduction potential. So all of the reactions that is occurring will be written as reduction form, and they have a value called reduction potential. The half cell that is in which reduction occurs has the greater reduction potential than the half cell with the oxidation, right? So now we have several half cells like this in the table. Then they will have values over there with reduction potential. The one with the greater reduction potential, greater mean more positive, صح? The more positive reduction potential is the one which will undergo reduction. So we expect them to be like this. Here's the 0 with the hydrogen electrode or the half cell. Then these are negative, assume. So these will undergo, madam negative, they will undergo oxidation. And these, the one which is with positive, is the one will undergo reduction. If we are comparing between two positives, the more positive one, يعني نفرض في واحد هنا 0.3 and then we have 1. This is the one which will undergo reduction, and that is oxidation. If we have positive 1 and -1, then this is oxidation, that is reduction. If we have -1 and -0.5, this is oxidation, that is reduction. So as you can see, the more positive, less negative is the one which will undergo reduction from the reduction potential table. Now, how are we going to determine that? That is the question. For the whole cell, if you want to determine that, we agreed that we cannot get the isolated one, but we can do the difference. The difference is what is known as the cell potential, and that is equal to the reduction potential of the one which is occurring as reduction, minus that the one which is occurring as oxidation. The number that you get over here is what is we call E of the cell. Now, E of the cell, that is a general thing, because we have to use standard one. Why we need standard ones? Because these, when we imagine that this is happening at certain set of condition, and this is at another set of conditions, then we did this experiment again, and we changed the conditions, then this value will be different. So for that reason, we need to use standard ones. And the standard means that we run it under standard condition. What are the standard conditions? 1 atmospheric pressure, and 25 degrees C. We're going to add to that 1 molar concentration of the, because remember that any electrode is a piece of metal that is dipped in the solution. Now the concentration of that solution has to be 1 molar. This is the standard conditions. So if we have such a standard conditions, then we're going to say E standard of the cell, which is at these conditions, is equal to the E standard of reduction plus minus the one which is undergo reduction. So all what we need to do is to find out these and then determine that. Okay. Now, in order to find out these, we said that we cannot measure a half cell that is isolated. We always look for the difference. So how gonna determine those? That's why they need something which is as a reference. And that's why they created the standard hydrogen electrode. The standard hydrogen electrode is basically a hydrogen electrode that has been assigned a zero value reduction potential. يعني عطوه zero زيه زي الزيرو تبع الأرقام. Okay, so it was assigned a zero value. When it has a zero value, okay, here's the, well, let me show you the picture. Here it is. This is our standard hydrogen electrode that has 1 molar concentration. It has a pressure of 101 and it's operating at 24 degrees or 25. So this is standard, and we give this the reduction potential for that one is equal to 0. All right, now I will assemble a cell where I have here the hydrogen and here I have any other element, X, let's say. Then I connect them and I measure the difference, which is the E of the cell. I measure it, I have a value. Now this value, according to this equation, is equal to the E, the one which is reduction, minus E of the one which is oxidation. Which one is reduction? Hydrogen. And which one is oxidation? The X, element X. So hydrogen is 0, then X is equal to the E of the cell. And this is the way we can determine. So what they did is they assembled electrochemical cell for each and every element with the hydrogen. And they measure it. That value is equal to the one which is called reduction potentials. Now you want to notice something about the reduction of hydrogen. It is with a double arrow, which means that it can be sometimes as an oxidation, sometimes as a reduction, depending on what? Depending on the other half. Because we agreed that if we have the hydrogen electrode here as with 0, there will be some negative values and there will be some positive values. Positive values يعني reduction. So if we select any of those, then hydrogen will be oxidized. But if we select any of those, hydrogen will be reduced, because then this is the one which will undergo oxidation and this is the one which will undergo reduction. So for that reason, it has a double arrow. Either will go this way as a reduction, or it will go backward as an oxidation. All right. So which one, how we decide whether it will go in that direction? Whether it's going to go in that direction or that direction, which determines that? It determines the other half cell that is connected to it. And the value of reduction potential for that one is the one which will decide whether this reaction will go this way or that way. Right. Standard reduction potential, as we said, that they were determined that like this. This is the hydrogen, they put it over here, and this is for the zinc. We put zinc, for example, and we connect them and we read the electrical potential, E of the cell, is equal to, according to the meter, plus 0.76. Okay, now where's the hydrogen in this case? In the cathode, which means that this is the reduction and this is the oxidation, right? When they did that, okay, E of the cell is equal to plus 0.76, and that is equal to the E of the reduction, which is E of the hydrogen, minus that E of the zinc. Standard. How much is this value being assigned? 0. So we have, another word, 0.76 plus is equal to 0 minus E of the zinc, which means that E of the zinc is equal to what? Negative 0.76. So we were able to determine the value for zinc, and we can do the same thing for any other element. Just put them in here and measure, and then do the equation using the value 0 for hydrogen electrode, and this way you can determine that for everyone. Now, what is the meaning of being 0? That's the most, being negative. Being negative, that means here we put it as oxidation, and we get the value of negative. This means that it doesn't like to be oxidized, but like to be reduced. So that's why the zinc is assigned into, zinc is assigned here to the anode, but with the value which is negative. Now, when you add the two half reaction, this is what happened at the anode, this is what happened at the cathode. You add them together, you cancel the electrons, then you get what we call cell reaction. Cell reaction is coming from the adding both reaction, the oxidation and the reduction. This is the cell reaction that we're talking about. Now, when you apply, as I said, you put E of the cell, which we measure it as 0.76 positive, E of the reduction, which is 0, and minus E of the zinc. So this will give, the value is E of the zinc is equal to negative 0.76. What does the negative means? The standard reduction potential for zinc is negative 0.76, which means that the tendency of zinc ion to become reduced in the metal cell is less than the tendency of hydrogen. يعني هاي الهيدروجين وهو less than that, negative values here. Okay, that's taken us to the table. Now I want you to focus on this table. This table will replace the activity series that we used to do. It is the same thing. If you remember, lithium was in the top, right? And if you want to also remember that zinc is above copper. Where is zinc? Zinc was. Zinc is above copper. Copper. Remember that in the voltaics. So you can see that the hydrogen is here. That is with a 0 value. في عندنا إشي positive, which is going to be reduced. وفي عندنا أشياء negative that is going to be oxidized. As you can see here, as we go up here to the negative, high in the negative, معناها the least tendency to occur as reduction. And more positive, that is the one which will undergo reduction. And the one with the negative will undergo oxidation. I will teach you a rule that you need to remember, that the more positive, less negative is reduction. شو معناتها الكلام? If I have two values, one of them is negative and one of them is positive, meaning two half cells. Which one will undergo reduction and which one will undergo oxidation? The one with the positive value is the one which will undergo reduction. Okay, we said more positive, less negative. That is reduction. طيب لو كانوا ثنتين positive, the more positive. اللي لها positive أكثر. طب لو كانوا إذا positive negative, that is the easiest one. The positive is reduction and the negative is oxidation. But if we have two positives, then the one which is more positive. طب لو كانوا ثنتين negative, the least negative. يعني مثلا compare هذا اللي هو negative 0.36 مع الألمنيوم, which is المعمولين بالأحمر. This is negative 0.036 and that is negative 1.66. Which one will undergo reduction? This one, the iron. Why? Because it is less negative. Okay, this is a rule that you definitely need to understand, because here's the challenge from now on. You will be asked, first of all, to decide if you were given two half cells, which one is oxidation, which one is reduction. If we provide you the table, you should be able to decide based on that. More positive, less negative is reduction. The other one by default is going to be oxidation. هذا number one. Number two, that we will be asking you to write the cell reaction. If we ask you to write the cell reaction, then this means that you have to decide which one is oxidized, which one is reduced. Then you write them in the right form, meaning that the one with the more positive still will be, if you look at these reactions over here, they are all in the reduction form. صح؟ طيب افرض انه احنا we are going to add the iron هذا تبع ال 0.036 with the aluminum which is 1.66. We agreed that this is the one which will undergo reduction and that is oxidation, which means that we're going to write it the opposite عشان يصير oxidation. مظبوط؟ Then we write it the opposite and we cancel the electrons and we add them. If we have to multiply by a factor or to invert an equation, we don't change the reduction potential. مش زي الدلتا H. Okay, if you remember in the delta H, multiplying by a factor, لأن هذاك اسمه molar heat. هذا ما اسموش molar reduction potential. Okay, it's just a reduction potential for a half cell. And that is not related to the mole or the molarity. Okay, because all of these are happening at one mole. عشان هيك it's a standard one. طيب خلينا نشوف هالكلام ان احنا بدينا نفهم او we can use this as an example or not. طيب let's read this question and try to answer it يعني the best way. In a voltaic cell كان في عندنا voltaic cell, one half reaction of the voltaic cell يعني واحد يا الكاثود يا الانود هو عبارة عن iron plus 3 electrons to produce or to reduce to iron. Which of the following will happen as oxidation? أنو A ولا B ولا C ولا D will happen as an oxidation and why? How you can decide? بدك ترجع للتيبل وتشوف reduction potential تبع هذا. أنا بقول لك إنه هذا راح يكون negative 0.3.036 والهيدروجين 0 والألمنيوم negative 1.66 والبي ار خلينا نرجع نشوف البي ار وبعدين من البي ار والايرون هذا تبع 2. البي ار is here positive 1.07 والثاني اللي هو هذا مظبوط 0.77. خلينا نرجع backward ولا forward. إذن هذا positive 1.07 وهذا positive 0.77. Okay. إذن هو بقول if we have a voltaic cell, هاي الفولتايك سيل هاي واحد وهاي واحد هذول التو half cells. طيب هديل بتقول بي. ليش بي؟ طيب يا هديل أنا ما بدي جواب إنه بي ولا سي. I want to know why. Okay. So هو بقول إنه واحد من هذول is iron. Then which one of those will occur as oxidation? يعني هذا الايرون نحطه هون. Iron 3 plus 3 electrons to produce iron is here in the reduction in the cathode. Which one will happen here as oxidation? عشان يصير oxidation لازم يكون more negative. مظبوط؟ لأنه هاي الايرون is here. Anything like this هذا وهذا وهذا الهيدروجين اللي هو A و C و D, all of them are more positive than that. More positive يعني reduction. احنا بدنا اياه يكون ايش؟ Oxidation. It has to be more negative. That's why the answer is B. يا هديل صح؟ مش the lowest. شو the lowest? It has a negative. Oxidation means negative. It's not always like that يا هديل. It is true that negative is always oxidation if we are comparing positive to negative. But if we are comparing negative with negative, then the reduction is the least negative and the oxidation is more negative. عشان هيك iron is negative 0.036 والaluminium is negative 1.66. So the negative 1.66, which is more negative, is the one which undergo oxidation. Okay, Hadil, you got it? So positive with negative هذا أسهل شيء. يعني when this is negative وهذول positive معناها واضح إنه this is going to be oxidation هذول reduction. معناها مش صحيح. These are not a good choice. This is negative مع 0 also is not a good choice. By default is going to be this one, but also it is more negative. So that's why we say, what is the reduction دايما؟ هو more positive less negative. Okay. طيب. Let's see more examples. And this is the, whatever examples I'm showing you is the typical type of questions that usually will be asked. This is one. Okay. Now, before, this is the rule that I'm telling you about. If the cell reaction having the more positive or less negative reduction potential occurs as a reduction in the cell. Now, how to calculate the E of the cell? We always have to use the one which we already stated. E of the cell is equal to the E of reduction minus E standard of the oxidation. عشان تقدر to calculate this one, before that you have to decide which one is oxidation and which one is reduction. بدون ما تعرف, إذن the key thing in this whole process is to use the table to decide which one is oxidation and which one is reduction. أي two half cells that they provided to you, you need to find out their reduction potentials from the table. And on that value, based on this rule that in front of you, you decide which one is oxidation, which one is reduction. Once you know that, you can do two things. First of all, you can calculate E standard of the cell. The second, you can write the cell reaction, اللي هو adding the two reactions together. خلينا نشوف بعض examples. طبعا إذا we calculate the E of the cell and found it to be positive, this means that it is spontaneous. ليش يكون البوزيتيف spontaneous؟ إذا كان هذا E standard of the cell is equal to positive value معناها spontaneous. طيب السبونتينيوس من وين جاي؟ إنه يكون الأكسيديشن جاي في محله والريدكشن جاي في محله. لما الأكسيديشن اللي هو عبارة عن more negative معناها اتذكر هنا this is E of the reduction minus E of oxidation. لما يكون هذا more negative وهذا more positive, positive minus negative يصير positive. فالجواب بيكون كله على بعض ايش؟ positive. That's where we have a spontaneous. اما اذا طلع negative معناها بيكون positive minus positive. positive طبعا هاي بتكون اكبر more positive وبالتالي الجواب بيطلع negative. عشان هيك بيطلع non spontaneous. Okay, but anyways, until you can do that to calculate. Hey, another example, which is show, you have to prove to the who is asking you the question that this reaction is spontaneous. طلع الرياكشن هو عبارة عن oxidation of zinc and reduction of silver. معناها I need to convert these two into half reactions. الhalf reactions هم عبارة عن zinc going to zinc 2 plus 2 electrons والsilver plus going to silver metal plus 1 electron. هذول two half reaction I have to go to the table and find out what their values are. And I can tell you that the zinc جربناه هو negative 0.76 مظبوط. وهذا is positive 0.8 مظبوط. طيب try to calculate E standard of the cell is equal to the E of the one which is undergo reduction, E of the one which is undergo oxidation. مين اللي صار له reduction هنا؟ silver. ف this will equal to positive 0.8 minus negative 0.76, which is positive, that is positive 1.56. عشان هيك you can show that this is a spontaneous reaction. But this is another way of asking the question. السؤال الأول كان which of the following will be oxidation إذا كان إن هذا is half a cell. The second one is if we provide you with the cell reaction. هذا اسمه cell reaction. This is made from two half reactions. Then you can decide whether this is spontaneous or not. This is again what he did, writing the two half reactions finding the reduction potential from the table, applying the equation, which is reduction minus oxidation, positive minus negative, that is plus. So E of the cell is above 0, and that is, it means that it is spontaneous. Okay, right. What other examples that we may have? Here he is providing you with the half cells along with the potential and ask you to determine the cell reaction for the voltaic cell. He's saying voltaic cell, which means that the one which is undergo oxidation will have more negative, and the one which has the reduction has to be more positive. يعني انت you can, based on these values, decide which one will undergo reduction, which one will undergo oxidation. مين اللي راح يصير له reduction in this case؟ الايرون ولا النيكل؟ الايرون. ليش؟ لانه بوزيتيف. تذكر احنا قلنا هاي اسهل حاله انه يكون عندنا بوزيتيف نيجاتيف. واضح البوزيتيف is reduction والنيجاتيف is for oxidation. معناها all what I need to do is to write this in the right form, which is nickel solid goes to nickel 2 plus 2 electrons. طيب هذا 1 electron معناها I need to multiply this by 2 عشان هذا يصير 2 هذا 2 وهذا 2 بحيث ان 2 electrons you go with the 2 electrons, and then at the end of the day it will be 2 Fe 3 plus nickel solid to produce nickel 2 plus iron 2 plus 2. Okay, this is what he's determined the cell reaction. Just write it this way. So this is another type of question that you may have to face. So first of all, the half cell with the more positive reduction potential is the one which undergo reduction. That's the cathode. The oxidation reaction occurs at the anode. Add the half reactions, making certain that the number of electrons are the same. مش ممكن تضيف 2 reactions without making the same. Iron is the one which is getting reduction in the cathode. This is the one in the anode. The voltaic cell is the iron is reduced, the other one is oxidized. Then this is the way it is. You multiply this by 2, okay, and then you add them together and you end up with this equation, which is I already wrote for it. Okay, electron lost has to be equal to the electrons gained. طيب the question here is asking about the same example, but here he's asking to calculate the standard cell potential. The standard cell potential شو بيساوي؟ E of the reduction minus E standard of the oxidation. مين اللي صار له reduction؟ الايرون اللي هو equal to 0.77 minus negative 0.25 يصير plus تجمعهم بيطلعوا 1.0 maybe 2, yeah, 102 positive. Then it is a spontaneous reaction and the value that he is asking for is 1.02. Even هذول هم forms of questions that you may experience. Here's another one, the last example. Determine the cell reaction for voltaic cell composed of the following half cells. هذول 2 half cells. In order to determine the cell reaction, you need to add them. But before you add them, you have to decide which one is oxidation, which one is reduction. طيب, both of them are negative. مش positive negative. لو positive negative يكون أسهل شيء. اللي هو positive is reduction والnegative is oxidation. طيب, when we have them 2 negatives, the least negative is the one which undergo what? Reduction. So this is the one which will undergo reduction, and this is the one which will undergo oxidation. معناها هذا لازم نكتبه بشكل oxidation, which is aluminium plus 3 electron. I'm sorry, to produce aluminium 3 plus 3 electrons. هاي electrons مع electrons, you add them up, then it will be iron 3 plus aluminium solid to produce iron solid plus aluminum 3 plus. So the aluminum has been oxidized and the iron has been reduced. This is the answer that he's looking for. This is the one which will be in the choices that you need to get. Okay? أعطيناكم كل احتمالات الquestions that is possible in this case. All right? Okay, that's what we have for today. But let me just summarize the things for you again, which is the fact that the electrical potential for any cell is result from the competition for the electrons. طيب, you can determine the standard potential for have a cell by using the hydrogen standard hydrogen electrode. ليش؟ لأنه الهيدروجين electrode is with 0 value. Then connect anything to it, measure it. The difference between them is equal to something minus 0 or 0 minus something, depending on whether this is an oxidation or reduction. This has already been done for you, and you don't need to assemble an experiment in order to determine one of them, but you can use the table, which will be provided to you in the exam. This is the equation that we're using, and also the other fact that whenever we have the E of the cell is positive, that is spontaneous reaction. Whenever it is negative, that is a non-spontaneous reaction. Okay? Do you guys have any questions? So there's one more lecture left, which is for Tuesday. Tuesday is going to be Ramadan, inshallah. So I will be giving the lecture from home, and you guys will be home. I have to go home. And after that, it will be review classes where you will decide what you want me to do for you. Examples, topics, one chapter, one section that you guys are interested to repeat, to review. That will happen starting from Thursday till the other Thursday. Okay? What about the time of the class? The same thing. There's no change at the time of the class. We're not changing that. But we said that during Ramadan, if you have any classes that is around the iftar time, that will be rescheduled with your instructor. Other than that, everything is the same, except that all the classes in Ramadan will be online only. ما في hybrid, يعني ما في تجوا على classes. Anyways, in your case, not too many of you. أنا كل مرة بكون عندي ألينا وفاطمة اليوم ما جتش. الصبح بكون عندي جودي. That's it. كلهم اثنين. All right? Okay? يلا. We'll speak to you inshallah on Ramadan Kareem. Ramadan Kareem for you يا عبد المحسن. Everybody كل عام وانتم بخير. إن شاء الله ربنا يتقبل منكم الصيام والقيام وبلغنا رمضان لسه ضايل يومين بعد. Okay? يلا. سلام.
شكرا.
باي.